All right. All right. Well, welcome to Tellus Science Museum's Lunch and Learn today. Want to first tell you about some of our upcoming events that we have. This week is Spooky Week, so if you come by the museum, you'll see our decorations that we've got up for the week. And come in costume if you want. That would be great. We've got lots of people walking around in costumes, both employees and guests. Next week on Friday evening, we have opening of our latest temporary exhibit, Out of This World. The preview will be online, and it'll be a Facebook Live event at 7 p.m. And then Saturday is the Solar Sky Watch. That's the following day, November 7th. So we'll have the telescopes up, and we'll be looking at the sun safely, of course. And then that also is a Bank of America weekend. So come if you're a Bank of America card holder. Come with your ID and card, and you get in for free that weekend. And then on November 11th, we have our Ask the Expert event at 2 p.m. With Bob Gossman, and we're going to be talking about solar energy. And today at our Lunch and Learn, we're talking about a cicada emerging in Opal. And we've got Brian T. Berger here, graduate gemologist, owner of the Velvet Box Society. He's also the owner of the specimen that we actually have here at Tellus on exhibit. So he and his colleagues are going to tell us about that specimen, and that includes Dr. Boris Chauvire from the University of Grenoble-Alpes in France, and Michal Huadria, Dr. Michal Huadria from the Institute of Entomology in Branisovska, Czech Republic. And we're going to jump over to Brian, and I think you're going to tell us about getting Beverly and a few other things.
For sure. Thank you so much. I guess I'm extremely honored to be given the opportunity to, number one, display Beverly, the bug, and share its uniqueness with the public. First, I want to express my gratitude to everyone at the Tellus Science Museum. If you guys don't know, they're a great museum in just outside of Atlanta in Georgia. And they've been incredible to work with, great people. They were able to put this all together with such speed and accuracy and efficiency. I really appreciate all of your hard work, and particularly you, Ryan, and Jason, and everyone else who was able to put this all together so fast and get her in there. And I'm sorry to have bugged you with this, for lack of a better way to put it. My name is Brian Berger. I'm a graduate gemologist in the Philadelphia area. My company is at Velvet Box Society. I've earned some special awards in gemology, both in the field and, obviously for having some unique specimens such as this one, such as Beverly. Additionally, I'd like to thank Boris and Michal, who are absolutely outstanding scientists. I can't speak highly enough of them. If you have questions in entomology or, geology, gemology, Boris and Michal are some of the top scientists in the world, and it was a pleasure to work with them. And I really appreciate all that they've done to push this study forward and, really create some knowledge behind such a unique specimen. I guess I first acquired the bug a few years ago, and I guess in the area I'm known for purchasing sort of unique gems, minerals, finished jewelry, antique pieces, a little bit of everything. And the bug actually came to me from another dealer who had acquired the purchase overseas, and then sort of found me and brought it to me. And when I first heard about it, I thought, this can't be genuine. But I always say, let me take a look. I'm always interested in unique specimens. So I thought, let me take a look, and let's take a look at the specimen and see what we have. So upon examination, I thoroughly studied it under microscope and loupe and tested it, and everything seemed genuine to me. So then it came down to actually acquiring the piece, which I was very fortunate enough to be able to do. And I guess for me, most of my background is not necessarily in mineral specimens and minerals themselves. So I'm more, more into polished gems. So though this wasn't my first experience, it was sort of a unique experience for me. But sort of the processes sort of carry over, in that examination. And obviously with the top scientists in the world, Boris and Mikhail, it was such a great experience, like learning and using some of the best equipment in the world and really diving much deeper into such a unique stone. And you can see, I think you guys have that specimen displayed there, so you could see that's a picture that I took, right after I actually acquired it, before we had any concrete information on it. After I acquired it, I guess my first step was figuring out what exactly it was. I mean, I knew it was an opal. I knew it had an inclusion. I knew it was an insect inclusion, but I had no knowledge or expertise in entomology, which is obviously a challenge because we're crossing multiple domains here. It's not just gemology and geology anymore. We're looking at the entomology side. So I first started out by looking for a place that I could sort of pull together a team of leading scientists to figure out how it formed, what the insect was, what happened, so we could sort of tell the story a little bit better than here's a one-of-one kind of specimen. So in doing so, I put a request out, to sort of find the right scientists, and I can't tell you how many hundreds of names came into my email and came to me. And after reviewing everyone, all their accolades and their just taking a look at the overall picture, it was such a great thing to find Boris and Mikhail and the rest of the team, quite frankly, who are some of the best scientists in the world for this kind of study. I mean, it was a broad-based team, and the team really, I couldn't say enough good things about them and how they were able to, study this in each different channel that it needed to be studied and really bring forward such incredible research to, the future of gemstones, the future of entomology, and the future of, as Boris will probably tell you later, tracking life, which is, something that scientists all over the world have been trying to do for quite some time. So, it was a real honor to work with them. And again, working with the Tellus Museum, great people. If you guys don't know, please go out and check out the Tellus Museum, not just for Beverly, although in my opinion, she's an outstanding specimen, but the rest of the museum is absolutely incredible. So I really want to thank all of you guys for for your efforts. It's been a real pleasure. If anyone has any questions, I'm happy to answer questions. Ryan, if you have questions, you tell me how you'd like to.
Well, very good. Well, we're going to start
to
here.
Manage here.
Awesome. We've got the paper that you guys wrote was, and Boris was the lead author with Mikhail and you in that paper, in Nature Research Scientific Reports. This was arthropod entombment in weathering formed opal, new horizons for recording life in rocks. And as the lead author in that paper, I want to see what Boris has to say about this specimen and the research that your team did together. There were 7 authors total on the paper, including you 3. And start with Boris on what he, the vision he saw for this when he found out about Beverly, and then where this goes, like you said, this research about understanding opal in life.
So hi everyone, and thank you for the invitations. First of all, I was really honored to work with Mikael, but we already know each other, and also with Brian, and with and to work on this specific sample. I saw the first pictures of the sample on the internet, so I contacted directly Brian, like he said, and I was really honored to be chosen for these investigations. So the first time we see the sample, it was really amazing because I'm a specialist of opal, and I have seen a lot of things about opal with plant roots inside, with a lot of things as inclusions, especially mineral inclusions. And here it was really amazing to see some things more complex than plant roots. And so yeah, it was really amazing to have the opportunity to work on these samples. I don't know if you want to go deeper in the science part yet or not.
Certainly, if you have some aspects that about the opal that you want to share, we would love to see where your expertise as an opal expert it tells us more about this specimen.
Oh yeah. So yeah, I will share my screen if it's okay. Yep.
Yes.
Yep. And so just to be, is everything okay? You see everything?
Yes.
Yeah, perfect. So just to just have a small reminder on the formations of opals. As you may say, on Earth and on Mars, the surface is composed by silicates, like other minerals that you may know, like olivine, feldspar, and something like that. On Earth and on Mars, we know that there is some liquid water. On Earth, we observe that currently. And on Earth, we see that there is some geomorphological evidence and mineralogical evidence of water that have flowed on Mars several billion years ago. And when we put some liquid water on this kind of silicates, you will have reactions, we call it neutrolysis, and you release some silica. And this is this silica that will form the opal. To form the opal, or how do we say opaline silica, you can have abiotic precipitations or biomineralizations. This is the two main pathways for the formations of opaline silica. Abiotic precipitations, if some of you have already go to Iceland, you may have seen this kind of stuff. It's geysers, and when the silica-rich water just cool down, it will precipitate as opaline silica. So here you have a kind of opals that is really specific of geysers, and this is all silica here. And on Earth, we also have another way to have opaline silica is the biomineralizations. Here it's diatoms, so it's living in salt water and also in fresh water. Yeah, and as we know as we know on Earth, this is the main way to produce opaline silica is by biomineralizations. But on the only Earth or on Mars, we know that there is no such life. So all the opaline silica come from the abiotic precipitations. We already know that we have opaline silica occurrences on Mars. We know that for more than 20 years ago now. And here I have put together a map with all the occurrence of opaline silica of Mars. So it's not exactly opal, it's all the opaline silica, and opal it's a part of an opaline silica. So it's a specific opaline silica. So you see that on Mars, we have a lot of occurrences on Mars, and opaline silica help us to reconstruct the aqueous history, so to know where and when the water have flowed on the surface of Mars. And in addition, silica is also an astrobiological matrix with the preservations of organic matter. With this sample, before the sample, we already know that the silica is a good preservative agent for the organic matter, because the oldest fossil we know on Earth come from this kind of minerals. Just to go deeper on how the opaline silica preserve trace of life, we have three main processes, and we will talk about only one here. And we have the permineralizations and the replacements. So replacements, it's really simple. You just have fossil, it's totally dissolved, and you replaced all the materials with opal. And for the permineralizations, if you have already see opalized wood, it's exactly the same. This is the process that leads to opalized wood. And this is also the attunement. And here, in the case of these samples, we have a case of entombment. So we have a bug that is inside an opaline silica. One of the good points of the entombment is that we preserved all the organic matter and all the remains of the samples. But on Earth, we have observed entombment only on hydrothermal silica. So the silica that come from geysers, the silica that come from other hydrothermal activities. Here you have a small map with all the points of hydrothermal silica we know on Earth. So you see that it's really occasional on Earth. It's really specific at some point. And here we have the first time with this sample, Beverly, we have the first time bug that is entombed in a weathering opal. So an opal that comes from another way of precipitations, that is the weathering. And the weathering is very interesting because in the opposite of hydrothermal opal, weathering occurs all the surface on Earth, and we know that it also occurs on the surface of Mars. So this sample is the first way to really explore how the opals that form during the weathering of rocks that can contain fossils. So it's really open a new way for the research of life on Earth, also for like here in Indonesia, or also on Mars, when we know that a lot of the opaline silica we see on Mars come from the weathering processes. So this is very just brief summary of the paper, and this is what is the more interesting part for this sample. So it's really opened a new way to explore life, also on Earth, but also on Mars.
Well, very, very good. Thank you, Mikhail, for showing us that. The difference there. Well, Boris, sorry, Boris. The big difference then is that this being weathered material, that the rain and acids from meteoritical waters have taken out of the material versus the actual silica that's coming up through the heated water out of volcanic activity. That's the big difference. And so Mars not being active in that way anymore, maybe was in the past, we don't know. The only source then is any current flow of water or past flow of water on the surface of Mars that then is being a source of potential opal. And does that tell us anything about life? Do we expect to be able to find life preserved on Mars that way? Or is it just going to tell us more about the past history of weather on Mars by having actual weathered opal?
Oh, both. Now we know that silica and opal in particular is the most promising target for the preservation of potential Martian life. But also the presence of opal tells us that this is some kind of weathering of Mars, because opal doesn't occur in all types of weathering. This is a specific weathering with specific physical and chemical conditions. So this is really specific, and with opaline silica we can have both information on the possible weather or the interaction between the water and the surface, and also on the possible life emergence on Mars.
This is exciting science. So as you were looking at this opal, how were you able to distinguish that this was weathered opal and not hydrothermal opal? Because Indonesia, it was a very tectonically active locality, and so you could have had hydrothermal water in that environment in the past. So how did you distinguish between that potential source and the actual source that you figured out this to be?
Yeah, this is the excellent questions. In Indonesia, we know that the most productive opal deposits come from the red wing. We know that all the opal, we don't know in Indonesia opal like Beverly, like this kind of samples that come from hydrothermal. There is a lot of studies, the geological studies on the opal deposits in Indonesia, and this is typically red wing. In my report, at this point, I wanted to go exactly on this deposit to go further on the identifications on the processes, more specifically on the chemical and physical conditions that helps to preserve this kind of life, and not only the formation of opal, but now we know that in the area that the opal is found, we only found opals that come from the weathering of volcanic rocks. We know that there is no evidences of hydrothermal activities.
Okay, interesting. Now, thank you, Boris. And I wanted to ask Mikhail a little bit about now. We know that there is a bug in this opal. How did we figure out what kind of bug it is?
Well, even before that, we were already wondering where the head was, because in the first, when Brian first brought up this stone, there was a lot of speculation on internet on what that thing was in the stone. Some people came up with termites, I think, or ants, even ants, but actually, without the technology he put to actually detect the difference in the surface of the insect, and then smoothen the shapes and really reconstruct the entire bug, we wouldn't have been able to actually know that what everyone was thinking was the head was actually the forelegs of the insect. And this was a key feature in the insect to identify it, as well as the rostrum that was visible only through, what is it called, tomography?
Yeah, X-ray tomography.
X-ray tomography. Without that, I mean, there was no way of being able to identify that insect through a microscope or anything else because of the opacity the opal had. So when first time Boris showed me the tomography picture, it was a huge mess because the fossilization is so good that each individual hair on the cuticle of the insect is visible. It's fossilized. So even each hair is fossilized to give you the kind of quality of the detail you can obtain through this fossil. So the whole thing was a big mess because this was all being seen through some X-rays. So then Boris went through a huge smoothing of the shape and I don't know what kind of programs he used. But anyway, once I could see, oh, these are actually the legs. And these kind of swollen forelegs are typical of cicadas pupa. So we were really, and Boris actually did this in a very scientific way. And he hired me and another colleague to blindly identify it. So I didn't know what she was thinking, and she didn't know what I was thinking. And we came up with we concluded on the same insect order and subfamily. And then to really confirm this, we had to go and actually ask a few specialists their own opinion on the insect itself. Once we knew what insect order we had in front of us.
So that image that you're talking about, I think, is figure 3 in your paper, and we have that scan of that. And so the dark piece that looks central in the opal when you look at it are those forelegs that show up as orange here on this image here. And so that blue bit is the head, the red bit is the thorax where those legs are coming out of.
Exactly.
And then you have the abdomen. And so this was the scan that you did with the microtomography. So that's done with X-rays.
X-ray.
Yeah. It's like a scanner that, like for humans, just more. There is very good resolutions for very small objects.
But this is
exactly the same principle.
This is a lot of work, bro. The initial image is half as nice as what you get here.
Yeah.
Well, don't you have to take?
And it was quite nerve-wracking to watch it.
Oh, your specimen being put underneath that X-ray, and
correct.
Afraid that it might damage it.
Yeah.
So, Mikhail, then you had that identification. How did you figure out what stage of life it is? Because this looks to be one of the instars, or which is one of the molts of the larva. How did you figure out what part that was?
So there were a few criteria that helped actually. Once we had nailed it to being cicadas, and we collaborated with one of the co-authors, Krisky, who really helped on that. And one of the features, so you have between 9 and 12 different molds, pupa stages in the cicada, and in the first 3 initial stages, there are no eyes, apparent eyes in the pupa. It's completely blind. So the eyes only appear at the 4th or 5th instar, I think. So this is one feature that helps you know and where you are in the stage of this insect. And I think also with my colleague also worked a lot on the forelegs, and you have a different development as the foreleg as you go on in the different stages of the pupa. Maybe something we should mention also is that this kind of insects completely spend maybe a whole year or 2 or up to 13 years underground and feeding on basically sap from roots. So this is a very slow growing insect, and it spends a lot of time underground, which is also an interesting aspect of finding fossils of this type of really underground insects. It's pretty rare, actually, I think.
So, I actually here in Georgia we had an emergence of some cicadas this summer. So a lot of people are probably used to seeing the very last exoskeleton of these larvae, which with the big eyes before they come out. But so this was an earlier time period. So that's what's called an instar for all the viewers out there. Now, one question that I just had come in is about back when the X-ray was done on this opal, was there a risk of that technique potentially modifying the color or anything of the opal?
This is a tricky question. Not on the opal itself, but we know that inside this type of opal you can have some inclusions of minerals, and specifically some iron oxide or something like that. And the opal is totally transparent to X-ray, so there is no problems with it. But with some inclusions and also with the organic matter that is contained inside, we can just burn the organic matter with X-ray. So we have been really careful to just do small radiations to avoid any burning. So yeah, it can have some change in the color, but we have been really careful with that. And most of the time, I don't see any change with X-ray and opal, in my knowledge.
Okay, so basically the risk was other inclusions potentially being affected, and the actual organic matter of the cicada. Now, looking at your paper, it says that the first thing that covered that cicada exoskeleton was some zeolite material. And what's the difference of that silica source from the source for the opal?
Oh yeah, very interesting. The zeolite, it's another type of minerals that also found inside soil or during the weathering of the rocks. And this is also one of the evidence that this opal come from the weathering and not the geothermal activity, like the other questions you asked before. This kind of zeolites formed during the early stage of the soil development, because at the first time, at the beginning of the weathering, you will just release a lot of elements inside the water. So you will release silica, so it will be interesting for us after, but also aluminums, also calcium and sodium and all of that. And the first stage will be to precipitate all these cations. And these cations will precipitate inside the zeolites, and after you will have a huge excess of silica, and this is this silica that will form the opal. So the zeolite, this is the first step of the formations of the fossil and the sample during the weathering of the rocks.
Interesting. So to go with that, mentioning the zeolite forming and our discussion about the cicada, I want to pull up figure 4 from your paper and see if there's anything else you all want to add on this story. So here we see, and if Brian has something to say, go ahead.
While you pull that figure up, I just wanted to mention that, so to give the audience an idea, Boris and I had the specimen inside that X-ray tomography inside the machine for, I think, like, what, 16 hours or something like that. So it was quite a long time, and hence the reason I said quite nerve-wracking, because you know, we were just kind of like waiting, like what's going to happen is, you know, everything's going to be okay. And, you know, we did a lot of research on making sure that obviously the stone, you know, would be intact and everything would be okay. But, you know, there's always that risk. So, you know, it wasn't like a quick, you know, put it in a machine and it comes out. You know, it was 16 hours. And at the end, you know, during that time period, we had no idea if the scan would come out, like if we'd have to do it again, or, you know, what the end result would be. But the team, I mean, Boris put together, just the entire team, they were just outstanding scientists. I can't say enough. You know, like I said, I'm not in the my main background isn't in minerals. You know, I've dealt with some of the rarest and most expensive diamonds in the world, and brokered them, but this was a whole different insect or animal, the way you could put it. So yeah, it was quite an experience using that kind of equipment to do these scans. And, you know, the person who asked the question about the color, that's obviously was a main concern. Are we going to lose play of color? Or, you know, because that play of color inside the opal is, you know, sort of, not every opal has that play of color. So to have, you know, this combination of things in a single stone, it's truly remarkable. I mean, but I just wanted to throw that in there about the machine. So please continue, Boris. I love listening.
No. You have made a really good point, Brian, with this, because you really trust us with that, because we don't have. This is the first time that this kind of sample come from my hands, and also all the scientific communities. So this is the first try, and this was a win. But it was really interesting to have this kind of stuff, and to really try and to have someone that is really interested with the scientific part of the sample, and that can trust us to go further on this part. This is not all the people that have this kind of zones that want to just put inside an instrument like that, that can, we didn't know before, so we can have some damage, even if we make carefully. It was one of the danger. So it was really nice to work with someone that trusts us with that to do all the scientific. So it's all the team that was very key part yeah, grateful.
Yeah.
For that.
So I have figure 4 up here, which I think summarizes what we talked about with that life cycle of the cicada that you
Yeah.
identified, shows the zeolite in part B, and then the opal forming in C. And I actually had a further question about this, and maybe Brian can probably answer this. The person wants to know who actually found the original opal specimen, and how do they know that this inclusion was an insect inside there? How do they see it? Has this specimen been polished or worked? Is another thing I want to add after that.
So the original person who found the specimen is actually the miner, is someone I actually know, and they found it, and they were going to polish it, and I guess they sort of made a rough form of it originally, and that's when they saw something inside and were like, what is this inclusion, and how did this inclusion form? So they contacted a dealer. So they're obviously an Indonesian gem miner, and they have a mine there, and they contacted a dealer here in the United States who acquired it, and that dealer hence then contacted me, just because I'm known for obviously looking at more interesting and rare gemstones. So it sort of was a chain down the line, and once I had taken a look and verified that it was genuine, I think the next tipping point for me was finding out more information. So hence the reason I went on the hunt to put together the right team of people. So.
Well, thank you. And so with that, so that initial work that the miner did to kind of form that, nothing else has been done since on that specimen?
No polish, no treatment, nothing at all. And that original, I'm gonna call it a preform, I guess is the right terminology. That was particularly just to clean off the excess material that was on the outside of the stone. So it really hasn't been polished or touched. It's not like a finished gemstone that you would see, per se in a piece of jewelry or something like that. It's opal in its rawest form.
Oh, so then that small specimen that we see then is going to be more of the shape of the space at which this was preserved then. So it also gives us kind of geologic history of that internal vug, or that hole that it was in.
Debatable.
Yeah, I would say more.
Debatable.
I would say Boris can probably account for that a lot better than I can, because he's much more adapt to the actual physical science of the geology. I focus primarily on the gemstone part itself. So, but Boris could tell you, I'm sure, in extreme depth about how it was formed and the space that was there, and all about that kind of process. So I'll let Boris jump in here.
So yeah, on the shape of the sample, it's really, like Mikael said, it's really debatable. We don't really know why it is in this shape and why the bug is this side. It's really difficult to know at this point, because since the miner just put the stone away of the works that it's come from, the host work, it's really difficult to have much information exactly about the shape and all of that. So as a scientist, I will say that we don't know, and we can imagine a lot of things. We can imagine that this kind of shape comes from an ancient roots that has been dissolved and not the cicada. We can say that it's just a cavity that's come from the volcanic rocks. We can say that it's a lot of kind of
theories.
A lot of theories. So on exactly the shape, it's really debatable. So yeah. Let the imagination go.
So a question I have going forward with this specimen, what further science do you hope to do with it?
We can do a lot of things.
Well, something we can't do. Unfortunately, you can't do Jurassic Park. You can't, suck the blood out of the fossil and have that species back in. It was actually one of the downsides of this was you can't extract any DNA to try and see when this species was present, if this is a new species on Earth that had never been recorded before. All that was rendered impossible for two reasons. First, we already mentioned that it's a young instar, so it's second or third instar, so it's a very small pupa or larvae, juvenile. So you can't really do any identification, and DNA extraction is impossible on such old stones anyway. So there's no way of actually getting more information on the biological aspect of insect. Maybe on the opal, there's more to be done.
Yeah, on the opal and even on the organic matter outside the DNA, as said by Mika, we can do more with more powerful X-ray beam. For example, in the cyclotron, we can identify exactly which type of organic matter is inside. So this can be the other step. For me, as a geologist, one of the things that I really want to do is to go on the field, to go exactly where this sample has been found, and to really study all of that. The geological conditions that leads to the insect preservation, because this is the first time, so we need to understand what the physical and chemical conditions leads to that, to really understand how it forms. And no, we don't have all the funding to do that, but we will try to. And also we can go further on the samples to date the sample. Maybe there is new ways to date this type of samples, and also to really understand what the physical conditions leads to this with some geochemical analysis, for example. So there is the study we have done is only the first one. This is a ground descriptions of that, and we have a lot to do to go more. We know that there is other samples that just come out from Indonesia. So we know that there is something else to study. So there is a lot of things now. This is just the start of something big, I think.
One thing Boris and I had talked about is getting the funding, obviously, to go into the field and visit that mine site. So I've spoken, obviously, directly with the miner who found, and it's a tricky subject, because here's a miner who found a great stone and something that he did well on, and he doesn't. Part of him wants to know the science behind, and part of him doesn't want to give up his secret space. So yeah. It's a tricky quest, and obviously it's something we'd all like to know more about. I feel like with this study, and particularly probably with all gemstones, at least for me, from what we know now, we're learning we're still students. So I think that this study is to be continued, and hopefully we can get out into the field and get a better idea as far as the mine, the layout, the surrounding area, and get a better idea of how it was formed. And maybe this will give us, like Boris and Mikael had mentioned, a better insight to life formations on Mars. I mean, that's really and I think an important part of the learning process here was how this life could be formed on Mars, and there could be life records on Mars. And that's one of the reasons that I put together the team with Boris, and Boris put together the main team because of that factor. So I think it's like I had said, we're all still students. PhD, graduate gemologist, we're still students. We're still learning.
Well, thank you, gentlemen, for sharing this cutting-edge science with us. and we're grateful that here at Tellus we actually get to have the specimen through March. So if anyone wants to come see Beverly the bug, the cicada that is in Opal, they can come to Tellus Science Museum in Cartersville, Georgia, and see the specimen. And I think if I get any further questions from people online, we'll look on the on the feed on Facebook and answer them in line there, and I'll get back with you on any of those questions, gentlemen. So thank you again for presenting here at our Lunch and Learn.
You're welcome.
You're welcome. Thank you for the invitations.
Thanks so much, Ryan and the Tellus Museum, and thank you, Boris and Mikael. It was an honor and a pleasure to be here with you guys, and I hope everyone enjoyed.
Have a great day.
All right.
Have a great
See
day.
you. Bye bye.
See you.
See ya.